Hello, good afternoon, friends. Myself, Dr. Ramesh Bahadure from Sri Vasantrao Naik Mahavidyalaya Dharni. Today we discuss about the regeneration in invertebrates and vertebrates. In this point from BSc first year semester 2 students. So let's start the regeneration in invertebrates. First of all, we see the regeneration is the sequence of morphogenetic events that restores the normal structure of an organ after its partial or total amputation. So we see the different invertebrates shows the regenerative power. So first, Hydra, the cross amputation of Hydra led every part to regenerate to whole Hydra species. In case of the planaria contains the neoblast cells which migrate towards the amputated region and form the losing parts. Then third, the annelids, the blastema of the amputated region form of ectoderm, mesoderm and neoblast cell which coordinated in regeneration of the losing parts. So, how we see the Hydra and the planarian, one of the invertebrates, to shows the how regenerative power. Cross amputation of Hydra led every part to regenerate to whole Hydra species. In that case, the Hydra cut at the middle portion, the amputation, the regenerative part. So, we will getting the two different Hydra species from the one Hydra. So, that is the regenerative aspect. In the other hand, the neoblasts are involved in the growth and degrowth like that. In the planarian situation shows the tissue homeostasis along with the regeneration. The planarian having the huge capacity of the regeneration. In that diagrammatic presentation, you will getting the easier idea of how they get regenerate. In the regeneration of vertebrates, there are two different types of regeneration: epimorphosis or epimorphic regeneration, and morphollaxis or morpholactic regeneration. So, epimorphosis or epimorphic regeneration, this type of regeneration involves the construction of the missing parts of local proliferation from the blastema or addition of parts to remaining piece. For example, regeneration of the tail, regeneration of the limbs as well as the lens in andorans and urideals and other vertebrates also. In other case, morphollaxis or morpholactic regeneration, this type of regeneration involve the reorganization of the remaining part of the body of an animal. For example, Hydra, planaria and other invertebrates. For example, regeneration of the new individual from the body pieces. So, one of the example, regeneration of the limb. The regeneration begins from the three phases. One, the phase of wound healing or pre-blastema stage. The second one, phase of the blastema formation, and the third is the phase of de-differentiated and morphogenesis. So, we will see one by one. In the phase of wound healing, where the blood gets clot and migration of the epidermal cell from the basal layer of epidermis towards the center of the wound is covered with the epithelium. The phase of blastema, the second aspect, the phase of blastema formation, the cell get accumulate beneath the epithelial covering and form the blastema. Mesenchymal cells accumulate beneath the cap. The mesenchymal cell, blastema cells differentiate into the myoblast and muscle cell, early cartilage cells and cartilage. During the de-differentiation phase, the hyaluronate, the increase in the distal stump of the form blastema. And the third, the phase of de-differentiated and morphogenesis, the blastema begins to restore the part of which the limb was derived especially in the form of arm is removed, the blastema differentiated directly into the muscle, bone, cartilage and skin of the form of arm. So in that diagram shows how they get regenerate the limb after the amputation, wound healing, redifferentiation, early bud, the medium bud, late bud, pellet, early differentiation and the couplet. So in that animation we will getting the exact idea how they get regenerative capacity of the limb. See, then the regeneration of the limb, see in that diagrammatic presentation or 3D animation, you will see the exact idea of regeneration in the limb. So this is again the outline of the regeneration of the limb. Epimorphosis or epimorphic regeneration, regeneration of the tail in amphibians and reptilian species. Everyone knows the basic phenomena of the regeneration in amphibia and reptiles. The best example is the tail. In case of the amphibia, the tail lacks vertebrate and has an unsegmented cartilaginous tube which contains the regenerated spinal cords which form mainly of the ependymal lining of the central canal. At first, very few cells accumulate under the wound epithelium. The epiderma and the various connective tissues, dermis, muscle septa, adipose tissues and osteocytes of vertebrate are the sources of cell for the generate. The non-nervous elements proliferate behind the apex, forming both the muscles and cartilaginous. In case of the reptiles, for example, lizard, the generate tail is a quite imperfect tail. It lacks vertebrates and in their place has an unsegmented cartilaginous tube. This tube contains the regenerated spinal cord, including the extension of the epidermal lining of the central canal of spinal cord. Then regeneration of the lens. Again, the second example, the regeneration in the lenses. The dorsal region of the iris thicken and cleft arises between inner and outer lamella of the iris. Amoeboid cell move from the stroma into the cleft. The pigmented cell of the dorsal region is angum. The form non-pigmented cubical cell from hollow epithelial vesicle. The vesicle's inner wall cells elongated into the lumen and form primary lens fibers. The lens-specific crystalline proteins. The primary lens fibers goes to front of vessels. The nucleus of primary lens fiber is enclosed. That is the regeneration of the lenses. So we will see in the diagrammatic presentation how the lens get regenerated, the iris part, and where the iris part and the lens get regenerated. In the second outline, the iris, the budding of the iris and the regeneration of the lenses at the elevation portion. In that way, this diagram shows the regeneration in lens. The factors controlling regeneration mostly on nervous system. Second, animal size. Third one is the pituitary gland. Then fourth one is the vitamin A and its derivatives and the insulin. These are the factors to control the regeneration. Thank you. Thank you for watching this video.